introduction, we did two things, but they're actually connected. Collections, you can see as, I suppose another word for it is grouping data. You can see it as making a folder with your data. Workflows is basically an analysis, right? But it's multiple analysis, so it's probably better to call it a pipeline. Okay, what we did after we did the introduction was, I gave you 10 files, and I asked you to import that 10 files to your computer. I'm just going to show it, follow along. We clicked on this button, we pasted, and some of you didn't use the paste function, but you could paste all of the files here, or you could go to choose local files and upload your files from there. But before you did that, you created a new history. And the reason for that is you wanted to make a new folder where you could put this new data in. So you can see you're creating a new history as a means to create a separate folder for new input data. The only thing is, besides the fact that it's a folder for input data, it's also a place where you would do analysis. And I think that's the part maybe where it gets a little confusing, because you see your data there and you see the tools that you ran in that space. But it's basically the same thing as putting your data there, running the analysis in the folder, and then you're seeing all your new output files being added into that folder. Right? You actually work like that anyway. It's just in Galaxy, so now it seems different. After you've created your collection, we went straight into the workflow space, and that was running pipelines. We started adding two tools, first FastP, and then we said, take the input, the data collection that we've just made in our new history, and run FastP on all of that data. Then we said, but because we have so much files, even though we run FastP, we don't want to look at each file individually, so we need a way to aggregate the output of that data, and we used multi-QC to aggregate all of the FastP files, so that we could properly see two of those files actually look different to the other 6 files based on the GC content. We then said, okay, but why is this file different, or these 2 files different? And is there another tool that we can use to figure out whether there was contamination? And then the only thing we did there was, I said, instead of running this tool inside this history that we're in, let's make a new history and call it Kraken, and then drag the file that we want to check for contamination into that new history. It's almost like making another folder on your laptop called Kraken and putting the bad reads into that folder, and then running the Kraken on that file, so that you know when you want to go back, you don't have to go to your old cholera dataset and find the bad files. You've already put them into another folder called Kraken, so that you know these are the bad files. So we took one file, the one that ends in 88, but there were actually 2, right? There were 2 files, but we just did it on one just for practice. And then we didn't actually run the tool because we said it was going to take long.
So there you don't upload the files that you ran the QC on, but the initial files.
Yeah, well, what do you mean by run? Because it's the same files. Are you asking the FastP ones, the one that you ran FastP on, that we processed? It doesn't matter. You can clean, because the cleaning doesn't get rid of contamination really. If it's a contaminated read, it will be throughout the thing. So you cutting off the bad parts of the read and getting rid of duplication or all of that won't necessarily change it. It will be a clean contaminated read. Right? So it will be like there was a human data or E. coli in there, but now it's a clean E. coli data. It was just dirty before. So it doesn't matter if you use the original file before we did processing with FastP, or if you use the old. Doesn't matter. And then it also doesn't matter if you use the forward or the reverse, because it's just the reverse. It's just we sequence forward on the E. coli and we sequence back on the E. coli. But technically speaking, it's like reading. I mean, probably bad. Give me a.
1 to 10 the other side.
It's like reading law that way and reading law that way. You know, it doesn't really. It's still going to be low. Now, if you want to really make sure it's low, you could read both files, but you kind of get the. So that's in a nutshell what we did.
So, hold on. If when you are doing market using it, when you have a reverse file, let's say the reverse and forward reads, they are not the same length. When you do trimming, they are considered the same length, right?
No, they will never be the same length, because the trimming you will do
So
depending on how you set your parameters.
So now the when you are picking the reverse, which might be longer than the other one, for doing Kraken, would it really?
No, it's based. It's again. It's just like saying, I have. If you have a file with, let's say your forward file is 5.8, and your reverse is 6.2. We are just saying we have more human data in here than in this file. It's like in
But
terms
that's
of
an assumption,
reads.
right?
No, it's not an assumption. You have more reads in this one because it's bigger. So you have more. So this is your. Are you asking about the contaminated file? Let me first
So
start.
just in general.
In general, let's say this was an actual Vibrio cholera files, both of these. This one just has more Vibrio cholera reads. So basically, now the reads are stacked, right? So it's just like this one maybe has two more over this region. If this is your reference over there. That's your reference file that you're comparing it to. These are your reads from your sample, right? You know how the right works, right? Okay. So it's basically just here you may have like slightly more read supporting, for example, let's say here's a GATTAT. There's just like there's more reads supporting that position, and maybe in this file where there's less, but in general just additional reads, maybe even longer reads. Some we can't exactly, because remember when they chop it up, it's like random in the library prep. But depending on what you're doing, because you guys do segmentation and whatever. But the one always has, there are flukes where sometimes they are exactly the same size, but generally the forward and the reverse read are never the same size. And because you're not cutting them, when you're trimming them, you are trimming them on quality usually. You're not saying bring them all to the same size. So they will trim all the reads that are, let's say, below 10 and below. It's a bad number. And so if your file has, your one forward file, for example, has more reads below that, it will cut more off on that file than on your reverse one. So you can't make them the same.
The concept is not making them the same. It's about you analyzing reads with different lengths.
Mm-hmm.
like when you are loading into Kraken that asks for a single file.
Yeah.
The differences,
So Kraken is going to take your sequences.
just one. Like,
No, it takes your sequences and it compares it to sequences in it. So all your reads. I don't know if I don't think it concatenates or makes a consensus. It can't. It takes your actual file with all of your reads. Let's say you have 100 reads in there, and it compares it to a database like BLAST. It compares it to a database with reads from other organisms, and it says we took these 100 reads and we consistently saw that it kept on comparing to the 60,000 reads of E. coli. Are you confused about how Kraken works?
no, my I don't know. My concern is it's as okay. Here you have two reads, forward and reverse.
But it's not.
It's only one
It's
file
not-
that has high GC content. She take only the file with high GC content.
But it doesn't tell you it's the reverse or the.
But it's not
You
one.
should know,
It's
but-
not one.
You are only putting one.
But it's not one read. There are many reads in the one file. Right?
Yeah,
The file looks like this.
Open the file.
There are many reads in the file. It's called forward reads
Yeah.
and reverse reads. So there's multiple reads in one file.
Yeah, but then the length is not the same. That's my. So
But-
if
but why
let's
do you
say
think
if you take something, if you load to Kraken something that has
Many sequence inside the file.
Okay.
High GC content.
Okay, I
And
think
then you put the other tool. Yeah. So when you give it to the tool, it's on the file. You put the file database. You see if this one is a species or different species, and it gives you percentage. Remember that table.
that one I understand. Perfect. So my I don't know I'm
This
just
is the
thinking that probably there can be some variations.
Ah, okay.
The variation if you load a 7 megabytes file and when you load a 9 megabytes file.
Probably.
It's one organism, as you are saying.
But that database will probably not have just one of the species in there, but it would have taken. So in the same way that we make a reference file from multiple different clinical strains or whatever, like an ancestral reference strain, it doesn't necessarily. So just because you're in a forward one, you have one long read, and you're saying we're putting that read into Kraken, and then here we have a short one, and we're putting that read into Kraken, right? And you're saying based on this having more information, maybe it will give a different.
Yeah.
But they're comparing all the reads. So it's very unlikely. If you just took one, then maybe it's a problem. But the file, the forward file here, has all of these reads. You know? So it's going to take all the reads. It takes long. I mean, if it was one, it would probably run through it. It's taking all the reads and it's comparing.
So for maybe it's my English, I don't know. Maybe it's my English.
I think
I actually understand what you're asking. She's saying if we're taking a forward.
Oh, I know.
think I didn't
Vice
ask the
versa.
same question, but
Yeah.
she says the reads and the reverse, the forward reads are equally the same as the forward, and Kraken is equally, even if you input the reverse of the forward, but I think it's kind of different. It's totally different to whichever
Yes,
result it
because
will give
there are
you.
instances whereby you find the forward reverse or the whatever.
Reverse, yeah.
The reverse and forward, they are not the same length.
Yeah, you find the
No, but
It's
it's not the same
yes.
length, but it's still a piece of the reference genome. So, okay.
So
If
the
you
question
compare a human reference genome to an equalizer reference genome to a cholera reference genome, right? They're gonna be different, completely different. So if I come here with a sample, and I've got a sample that chopped up human reads, right? If I compare to all three of those, whether they sequence this sample this way or that way, I'm comparing all the reads to this, then to this, then to this. I'm more likely to have more in common with the human one because it's all the reads. I'm not taking one small fraction of this forward files read and then taking a random section from there that may be longer. I'm taking all my reads. So eventually, technically, even all my reads, if this is the reference file, it may overlap most of the genome. Maybe there'll be gaps there. Now, I'm not saying this is doing any consensus, but I'm saying all of it combined, you're looking at one read. This file should not be called a read. It's reads. So it's called a forward and reverse file. It's not a read.
So if you have a forward that has, let's say, 10 nucleotides,
No, it doesn't. The forward will have 80,000 reads.
longer
That's-
than the reverse, then you upload it. It gives you a report. Then you upload the reverse that is.
What do you think is inside the file? Let's start there.
It's all those reads.
But why do you think it's taking one read?
Maybe it's just to cut time. I don't
No,
know.
it's taking all of the reads. That's what I keep saying. It's taking all of the reads in your forward file. And all of
Yes.
it.
That one I
For
get.
instance, whereby the pair end reads, you find the forward read has 98 base pair and the reverse has 100 base pair.
Yes.
Because you never find them being 150 or 158.
Yes.
There are some which have that.
Yes.
She's asking what is the difference between that, the 2 and B or whatever, the 2 can be. Could it have something in it that would not
Yes.
reference it on that marker?
But now you're talking about mutations. We are not talking about how it compares to an actual.
No mutations.
You're
Taking what
I'm saying it's more applicable to mutations when we're looking at short, but when we're looking at short pieces that are missing. What I'm saying is, if you look at this is a reference file, right? My arm is a reference file. I've got 10 million reads. They span almost my whole arm. I'm taking all of that reads. They're going forward now. The difference between the forward and the reverse is only most of the time that they don't overlap 100% completely the same read, but they will overlap most. The forward and in fact you have bad reads. If your forward or your reverse doesn't map to more than let's say 80-90% of the genome, you would probably chuck it. So you are mapping whether you're going forward or in reverse, you are mapping 90% of your reference genome. So you are basically, whether you're taking your forward or your reverse, you are taking 90% of the genome and comparing it to the Krausen database. So you are comparing 90% human reads to this. It doesn't matter if the reads, if there's a section where it doesn't cover it because it's looking at, there are more differences between a human reference file and a Vibrio cholera reference file. So much so that small spaces that are missing won't make it a completely different species. It will still be human, but it will just be, there'll be gaps in different places.
So in the place where you're saying select a single read in Kraken, so you select the reverse.
Yes, it's because
So
it's not a
in
read, it's a read file.
Okay.
It's the whole file with all the reads. That's why I keep saying don't call it a read because that makes it confusing. One file has hundreds, millions of reads that span your entire genome. And you're putting all of that into Kraken.
Yeah, but technically your forward read is essentially your reverse read.
Exactly.
You just are sequencing it in the opposite direction.
Yeah.
Okay?
It should be more or less. In fact, when you look at it, have you looked at the IGVM? you actually have to check if it's not 50% going this way and that way and they're almost 100% in the same spaces, you also have a bad read. It should literally be almost exactly the same, but the one will be colored red and the one blue, depending on how you put your colors. And you will see that they more or less cover the same spaces.
And the read length should be equal. I mean, your forward read length should be the same as your reverse read length.
Well, it's not going to be 100%, but it's going to
This is
be.
not the concept. That's why I'm asking. If the forward is not equivalent to the reverse, how do you just log one?
No, but you are seeing it when we are saying.
Because
Okay,
my question
you know
is
what
when
you're
say
saying.
They might not be of the same
No,
length.
but I know what you're saying, but you're saying the wrong thing. I'll tell you why. You're
That's something to do with my
confused.
English, but then
No, I know what you're saying. Okay, let me draw this again. Here's your reference, eh?
because you cannot tell me your loading things that are not equal in size to give you the same result. No.
Yes, I am. I
Yeah.
will show you.
That's
Okay, yes. Let's say this is the reference genome. Right? This is your reference. Can I have another color? This is your forward reads. Yes, that's your forward reads. This is your reverse reads. When we are saying this file is bigger than this, we are not saying it's longer. We are saying it has more reads. It's bigger in size because it has more reads. It can't go longer than the reference genome. It's going to fit
no,
in
not
here.
more than the reference, but more than the other.
Yes, but it's going to span like that. So maybe this one has a read here that's a bit longer, and this one has a read here that's a bit shorter. But they both cover, but the only reason why this one is bigger, this file is maybe 3 megabytes, and this one is 4 megabytes, is because it has more reads in it that covers the same reference genome, the same position. So it has maybe more support for there being, let's say, a C here. This one has only one support. This one has 4 supporting the C position. So when it's bigger, it's almost like it has, in terms of the length, they both cover, if your genome is 6 billion base pairs like human, they're both only going to sit within the 6 base pairs, billion base pairs, but they're gonna have, the forward may have more read supporting positions in that same length. This file is not longer. The forward file is not like that, and the reverse is like that. They're both the size.
I get that. But my thing is, okay, you have 2 files. This one, okay, these are 2 files. You have this, you have this. This is forward, this is reverse. Then you put this one on Kraken. So the results of
They
this,
don't have same
will it,
price. Number
Just
of
open.
lines, they're not same.
The result of this one?
will it be equivalent to this? Because
No,
if you are
it may not be
taking
100% equivalent, so maybe it will say something like 89% support for Eremonas in this one, and this one has 85% support. Right? But it will still say this is predominantly Eremonas and not Vibrio cholera. This is like the green one. I mean, I already moved this one. I don't know.
So I'll try. I'll
He's
try to
gonna
illustrate
try.
the concept. It may not be very accurate, but I'll just try and just reiterate what it's just illustrate. So let's go back to the basics. Let's look at what happens when you do sequencing. Okay. So this is my genome of interest, right? Whatever categories it is. And therefore, what tends to happen is that we fragment it, right? So we're going to chop it into pieces, sometimes overlapping, okay? And these pieces could be, they're often longer than the read length, right? So, and what I'm going to do is that I want to sequence these regions. Okay, so we start with a big genome, we cut it into random pieces, and we know the sizes. So then within the PCR reaction, within the lab work, we usually remove very short things, okay? Size selection, right? So we remain with something that's almost the same. So I'm just gonna grow this a little bit, and then we see what we have. So that is now our region of interest, right? So what we're going to do is that we're going to sequence this, and we're going to do it in both regions. So remember there are multiple chemistries, so we can do 600, we can do 300, we can do 150, and it used to be that we can do 50. Okay, so that's the length of the read. So the way we're going to do it is that we're going to sequence in this direction, okay, and we're going to sequence in this direction, okay. So this is your reverse read, and this is your forward read, okay. Now note that there's a region here that sometimes doesn't always overlap, okay.
Yeah.
But remember that we're doing this multiple times, okay. So in another read, we're going to do this. Remember that these things are overlapping, okay. So let's say we looked at this region, and now we're gonna sequence this. Remember it's overlapping with this, okay. So what's going to happen again? Gonna do the same thing, right? But then we have some overlap, and therefore some of it will be covered by the forward read. So part of this will be covered by a forward read, okay? So we want to assemble. So with Illumina, you get two files, right? So these two files here are separate. So this is the reverse, and this is the forward. And your question is that if we take the reverse and we hit it back at the genome, do we get the same information or other information from what you get with the forward read only, isn't it?
Yeah.
So
in the case where they are not equal.
yes. So remember that when we're doing all this, we're gonna do some cleanup. We're gonna get rid of errors and things that we don't need. We're also gonna clean up, remove primers, and remove adapters, which I've not mentioned about that. Within the forward read, we have to have a barcode and an adapter that's going to adhere on the cluster, because we're going to do synthesis by sequencing by synthesis. So we got this thing embedded on a glass frame, okay. So our file here, we got the forward reads, you can think of it, and you've got the whatever. So if you hit this against Kraken or centrifuge, the first thing that happens is that we get what you call k-mass. So again, so we're going to take our read over here, and what tends to happen is that we're going to split it into some overlapping segments, yeah, which is the length of our k-mass. And then we're going to take this and then compare it against a huge database of similar things. So you can see that if we do it only with this file alone, it's not sufficient to give us all the information that we need. Okay, and if we do with this only, it's also not sufficient. So when we give it here, because it's going to go back to our original segments that we were sequencing, which if we can assemble them, we got the whole. Yeah. So is it clear now? It is. What was the
Now you are
question?
saying it the other way around, because for here you load one, not both. Because my concept is if you load both, it makes sense. But if you load one, it doesn't give you.
I thought it was
No. Yeah.
Yeah.
We load one because the database consists of all the whole genome, so it will span. Whether it's forward or reverse, you will span most of the genome, and they will have overlapping sections. So you can feed it back into the original genome, the reference genome, and it should still be able to give you hits and say, remember we used to do it with even short sections, 1G, now we're doing the whole genome.
Yeah, she's correct.
But
Because
then it doesn't. I don't know. It's my conceptual understanding that it might work, but then we are working on something like maybe 70%.
So remember, in this case, we all just want to ask a very simple question. So remember that here maybe we don't want to assemble a gene. We're asking a very simple question, which is, is what I have consistent with something that you already have? Okay? And if that's the question, then very quickly, if you just roll one of them, it will answer that question. And it's sufficient because you also save on computational time. You don't need to do the same thing twice.
This is what I was telling her. I said, I think the main idea here is to save time because if you have to load all
Yes,
that,
but that's what I said. So we only do it on the one because it already took long on that one forward read hours. And this is a 5.8, this was 60% subsample, 60% smaller than the original file. And I mean you could still from that chopped file you could identify that it was colorless, so that again shows you don't need much because our genomes are sufficiently different for you to be able to take a short piece of that and say
whether you
I
have
can
a equal-
identify,
that's correct. You don't need everything to make that to answer that question. I think if that
thank you. The people are complaining.
no, it's good.
I don't know whether I was clear, but
I just want to add on
It's okay.
to what you were
But for me, it was like,
Yeah, if this
Yeah.
if
Yes,
there's
I suppose the question is,
point
if you already know,
one, so you give the option to go through.
And then tomorrow
For Carter, you have the option to
then you can say
give presents or
if
yeah.
you know in
So
yourself.
usually we'll go for like the less
And also put both reads into IGV, then you can see what the reads look like.
But the thing is set on default that you can only load one. So how am I going to
You can do separately.
2 jobs.
Oh, okay.
Yeah. If you need to prove it to yourself, and if that's the only way, you submit the job, get it done overnight, and then tomorrow
both.
give us feedback.
Okay.
You could also load both of your reads into IGV and see what the reads look like, the forward and the reverse. There's an IGV web, but you'll need a reference sheet of color. But maybe I will ask Peter to do that when he does the analysis, so that you can see what the forward and the reverse file look like. When you actually see it.
The forward and the reverse, how they look like.
Yes. We can show you what it looks like when it compares to the reference genome, how they overlap the reference genome. Like
No, the overlapping story, I know, I see. But my question is just was about the size. But I got it this. Yeah, it's fine. I got it this such. It's fine.
Okay.
Yeah, question.
But and in the summary of what we did, does it make sense? The difference between collections and workflows?
Yeah.
And then in terms of workflows itself, was there anything else that you needed, that you had questions on? Or that you needed me to demonstrate again?
Me.
Everybody?
Anyone?
You can be you too, don't feel bad because you asked a question already. You may ask, you may dominate the questions, it's perfect.
So you can run multiple
My
workflows.
question
You don't have
would
to
be,
Yeah.
can you, the workflow, okay, I have it here, so maybe
Okay.
I can ask from here. So when you reach the Kraken, was getting the data to analyze from the data, the collection. I don't know if
Not
that's
really.
what you-
We just made it like that in the workflow. So if you look at the workflow, the answer is yes. But if you look at it in terms of what you could do it that way, you could do it in one workflow, right? But what you would then need to do is you need to, when you upload your data into your history, you upload it twice. So that from the one, you can make a collection, and the other files you leave unpaired and not in a collection. Then you can sufficiently connect it to Kraken so that once you're done with multi-QC, you can then put in the file that you want to run through Kraken. And remember, when you are going to run the analysis again, you can change which files goes in. So you can select in Kraken which input file you want to put in there. Okay. But like I said, what I normally do is immediately, especially if I have like 200 data sets, immediately what I do is I copy the history. And I leave the one as a copy and then I work on the other one in the same way that you would not work on your reads, or you have one copy of your read somewhere that you haven't done any analysis on, and the other ones that you. So I would make a copy of it and then use the one history to do all my analysis, and then that one can be used to, like we did when we put the history side by side, to drag files into wherever I want to when I need it. Yeah. Because it's difficult to drag from. Maybe it's possible, but we haven't been able to figure out how to drag from a collection. Mika, do you have a question? No. Or you have it in French? Okay, are there any other questions? Just so you know, I did. This is literally everything that I did, from import, naming the workflow, checking the box and unchecking the box, select all, building it. Everything is, you could actually repeat this at home. We use the same data sets, the same samples, so you can follow it through. This is how to make a collection. And then the workflows is here as well. It shows you will run FastP, then multi-QC. The only thing is, I didn't put the options in for multi-QC, but multi-QC didn't have anything, no parameters. You just search for it and then you put the paired collection in and you ran it. But I will put it in there for clarity. Everything that we did, including the parameters that we chose, the questions we answered, how to use Kraken, it's all in there. How to create the workflow by extracting it, how to edit it, how to connect. It's all there. The only thing that we didn't do yet is, if you are in workflow and you want to import a workflow that already exists that somebody else has created, you can go here to import, and you will actually see that you can either use a URL from somebody that has a URL for a workflow, or you can go here to the GA4GH server. You will see it automatically on EU, but you can also go to DocStore. Then here you will search for the database, so the workflow. Like for example, there isn't one for cholera. So if you put SARS in there, let me just make this bigger. So there's nothing. I left this on EU. So again, when you click on workflow and you click on import, yeah, you're automatically on the archive file or URL. If you don't have it, or the workflow is not on your desktop, you can go to public servers and you can type in here SARS, for example. There's one for Sandy here somewhere. One that Peter made right at the bottom. If you click on it, this box opens up and then you can just click this and it will import the workflow. And you will now see the workflow is under your workflows tab. So you can actually go to a public database and look at pipelines that other people have created and import it into Galaxy and run it in the same way that you would run the workflow that you created. If somebody has the TRS ID, I don't have one now, but last time we used the ID. You could also add the ID to here. There's not as 5 something. But you can see it starts to populate, and you will be able to find the workflow here as well, using that way. But that's the only other thing I wanted to add, but again, that is also in the notes. You can import workflows. I'm hoping one of you will be able to create one for cholera, and then upload it to public repository so that we can download it. Peter them are working on the issue that Ndafa and Tuli had with the midnight primers for SARS-CoV-2. They are working on one to put into Galaxy, but it doesn't exist. But other than that, that is it for Galaxy. Again, if you get stuck, you can go through the tutorials that are on there. There's also, in terms of additional resources, there's a YouTube channel where you can find a whole bunch of Galaxy videos. It actually is quite nice. It cements it in to be able to see the videos and where you click and whatever. I find that if you actually start off with videos before you come to class, it actually does make it much easier to follow. As I said, all the tutorials are there. You can also follow conferences that are happening, like there's a hackathon happening at the moment. Mentorship. All these links work, right? You can click on it and you can find yourself a mentor on the Galaxy network. The mentor will work with you one-on-one, and you will basically be able to tell the mentor, what are your goals? Like, I want to be a data scientist. And they will help you follow Galaxy materials and additional materials to help you to become whoever you want to be. And there's special interest groups in the different projects, different areas that you may be interested in, monkeypox, whatever. If you need help, there's a chat group. Also, maybe none of you haven't really had this issue, but let me see if I can find my. If you end up running something and you have RAID like this, you can submit. If you open it up, there's a bug here, a little bug, like an actual bug. You can click on that and it usually tells you what the problem was. It tells you what the problem was, and it also allows you to report. So you can type here as much as you want about what the issue is, what the error message is, and report it, and somebody will, usually they actually do answer quite quickly. They will get back to you about what your problem is, empty file or something like that. And again, for those who are interested in deploying tools and things on Galaxy, that is available as well. And how to access the different servers on the different clouds. They are busy at the moment, but this is still in the infancy stages, to define learning paths where you can actually, again, similar to the mentorship, where you can choose what you want to become proficient in, and they will then recommend the path that you take. First do this tutorial in Galaxy and then you do that tutorial. So it's kind of like an actual course that they designed for you. But it's still starting. But that's it for Galaxy.
So, step before that,
Which one?
where you check the issues with the quality.
The bug report.
Yeah.
So if you normally it will look like this, right? You would just open it up, and then there's this bug here, the first button. It looks like a little insect.
Oh, double click on it. Okay.
No, you just click once.
Mine I need to double click. No, it doesn't show me.
Oh, oops! You should be able to click once. Maybe it's different on your machine. Maybe because I can click once on everything and click away. Click on the info button and then click back on the bug. Anyway, but this will kind of give you an idea of what it is. Sometimes if you click on the info button also, It can give you more information. And sometimes they do populate this with sufficient information so that you know why the job failed. Otherwise, the bug,
And then it doesn't
if
give
you,
sufficient information.
huh?
It's not sufficient.
In those stages, but sometimes they do. That's what I'm saying. It depends. I suppose it's like any tool that you use. If the error messages are well built into written into the tool, then.
Yeah, it is.
The other thing is, depending on the tool, how the tool was written. For example, Basic 2, if you want to do differential analysis, you can actually download the R files, the Python files. It will generate the files with the output, so that if you want to repeat this on your command line, you could just download the file and then run the R code, for example, on the. But again, it depends on the tool. I would advise you to read when you select the tool. Like I said, if you select the tool, you can scroll to the bottom. It's slow now, but you can scroll to the bottom. And is anybody else having internet issues? No. You can scroll to the bottom and you can read. This one doesn't have much details, but you can read what the input and the output of the files are. I think this is the fast PC. It does give you information about how to use the tool. And sometimes there you will be able to see that R code or whatever is available. Okay, I think we are done. It's 10 to 3. Tomorrow Peter will start on the command line with Backtopia. Anybody here used Backtopia before?